In Section A, students primarily focus on the Readiness Standard 7A. This is where students graph quadratic functions and identify key features and attributes. To launch students into noticing the behavior of quadratic functions, they begin by looking at patterns that grow quadratically. The examples in Section A begin by specifically comparing the perimeter and area of rectangles. Then, students contrast this growth behavior with the linear and exponential growth patterns they investigated in Units 4 and 5. Further observations lead students to uncover that quadratic patterns grow more quickly than linear patterns, but more slowly than exponential patterns. Notice from the lesson images that students are using both tables and graphs to determine the type of mathematical relationship that exists in the given patterns. Once they know what type of relationship exists, then they are introduced to representing the patterns with given expressions. This ensures that students understand and are able to identify what the three relationships look like in terms of tables, graphs, and expressions. I want to point out that the 2 lessons in Section A are only intended to act as a springboard into quadratics for students. They don't have to master any of these concepts quite yet. Now, for some instructional suggestions. First, to support learners with disabilities, consider providing students with graph paper or grid paper so they can physically count the perimeter and area if needed. Another suggestion I have is to build on what the students see themselves in the graphs. Use their observations, such as mirror line or high point, to emphasize attributes like the symmetry of the parabola or where the vertex of the graph is located. As you highlight the key features, you can start to guide students' use of the vocabulary. You can also add questions to help introduce terminology if students don't notice it. One of the graphs in the first lesson depicts the possible lengths of a rectangle compared to its area measurements. This graph also lends itself to additional extension questions such as, when is the area maximized and at what length is that? What are all the possible area values? What are all the possible lengths of the rectangle? Could there ever be an area that measures 0? Could the area ever be a decimal or a fractional value? These questions foreshadow key features of parabolas and can be used as a contrast with questions that we ask about potential maximum values for linear, or maximum values for exponential, or comparing the domain and range values between these types of functions. And one quick note, this is a chance to acquaint students with finite differences if they have not seen them before. Using finite differences as a way to analyze a table of values will give you a chance to ask what stays the same and what changes when looking at the differences. This sets students up for determining the equation or expression, which is the primary focus of the next section,